question number 6 for the AP Calculus AB 2024. Looks like a fun one. So the functions f and g are defined as given, and they're shown in the graph here. So we got f here, we got g here. And R is the region bounded by the graphs of f and g from x equals 0 to 2, as shown in the graph. Write but do not evaluate an integral expression that gives the area of the region R. Alright, these ones are easy. We like these ones. So how to find each region R? We don't have to do any sort of calculations. All we got to do is write an expression. So we'll say R is equal to the integral from 0 to 2. That's where this this region is taking place, from 0 to 2. And the region is just going to be the function above, which is f of x, minus the function below, which is g of x. So just area between two curves. Function 1 minus function 2. So that's going to be f of x minus g of x dx. And I'm pretty confident that this alone would give you any points that you need. Since f and g are already defined here, we know that that's what these functions are. If you copy these down into f and g, that's fine, but make sure that you copy them down correctly. But I'm pretty sure you can just leave your answer like this right here and get full points. Right, but do not evaluate an integral expression that gives the area of the region R. Yeah, I'd call that good right there. Okay, part B. Let S be the region bounded by the graphs of G and the x-axis from x equals 2 to x equals 5. Okay, so here's region S as shown in the graph. Region S is the base of a solid. So we have some solid that is on top of this region right here. And for the solid, each cross section, so if I take a slice out of it, it's perpendicular to the x-axis. It's a rectangle with a height equal to half of the base of it in region S. Find the volume of the solid. So we're trying to find the volume of the solid that is above this region right here, and each cross section is just a rectangle. So basically what we're doing here is we're going to do the integral from 2 to 5 of our cross section, area of our cross section. That's what we want to do, but we need to define a of x. That's what we need to do. So a of x is equal to, it tells us here, the cross section perpendicular to the x-axis is a rectangle. Okay, so I'm going to start there. Is a rectangle. Well, I know rectangles are base times height, right? And what is the base of this rectangle? So if the rectangle lies on top of this right here, well, the base is just going to be whatever this is right here, which is the distance from the x-axis to the function, which is going to be g of x. So I know that a of x is going to be g of x times by h. I still need to define what h is too, but that's also given to us here. So perpendicular to the x-axis is a rectangle with a height that is equal to half of its base. So h is equal to half of the base. Remember that we already defined that the base is g of x. So so it's equal to 1/2 of g of x. So if we plug that in here, we get a of x is equal to g of x times by 1/2 of g of x. And that's going to be equal to g of x squared divided by 2. So this right here is a of x. So let's go ahead and just put this in here. So we're going to say that the volume is equal to the integral from 2 to 5 of g of x squared over 2 dx. Okay. Find the volume of the solid. Show the work that leads to your answer. Okay. Since I am actually evaluating this integral right here, we'll do the integral from 2 to 5, and g of x, which is x squared minus 2x squared. I'm going to take out the 1/2. I'm going to put that outside here. Dx right there. And then let's go ahead and expand this right here. So x squared minus 2x, I'm just going to do some scribble work right here. If I FOIL this out right here, I'll get x to the 4th minus 2x cubed minus 2x cubed plus 4x squared. So I get x to the 4th minus 4x cubed plus 4x squared. So 1/2 of the integral from 2 to 5 of x to the 4th minus 4x cubed plus 4x squared dx. Okay, that shouldn't be a hard antiderivative, so we got 1/2. That's going to become 1/5 x to the 5th minus x to the 4th plus 4 over 3 x to the 3rd. We're evaluating that from 2 to 5. Geez. Okay, so let's go ahead and plug in 5. So we get 1/2. We're going to get 5 to the 5th divided by 5 minus 5 to the 4th plus 4 over 3 times by 5 to the 3rd minus 2 to the 5th divided by 5 minus 2 to the 4th plus 4 over 3 times by 2 cubed. Now this is where it's getting kind of scary, where you try and simplify much more than this, and you could really make an error in this right here. I mean, I know that this would cancel out right there. That's easy enough. But 5 to the 3rd, and you're going to have to multiply that by 4. That's a lot of arithmetic right there, a lot of multiplying. And you'd have a denominator of 3, right? This right here would be 2 to the 5th divided by 5. This has a denominator of 5. That's going to be 32 over 5 minus 16. This would be 8 times 4, 32 over 3. Very messy, a lot of trying to get a common denominator probably. You'd also have to distribute that negative. I'm hoping right now that the AP scoring guidelines, we'll see what they say when they come out, but hopefully this right here would suffice right here, because trying to simplify this, you really run the risk of making an error. So I'm going to say that this right here should give you the points, hopefully, if those AP graders are nice, because that's a nasty thing to try and simplify right there. But hopefully, yeah, I think that should cover it right there, and I hope I got everything right. Let me know if I messed up on any of the calculations there. Okay, I'm going to call that good for B. Final part, C. Write but do not evaluate an integral expression that gives the volume of the solid generated when S, as described in part B, is rotated about the horizontal line y equals 20. So say we have a horizontal line right here, y equals 20, and we're rotating this region right here. We're going to rotate it about this line right here. You get another type of a region right there. This is a washer method, yeah? Okay, so washer method, we need an washer method, if you guys remember. Volume would be equal to pi times the integral from a to b of the outer radius squared minus the inner radius squared dx. So we have to define what the outer and the inner radius is. So the outer radius, always measure when you're using washer or disk method, measure your radius from the axis of rotation. So in this case, here's our axis of rotation. That's at y equals 20. So the radius from here to the outer part of where we're integrating, this right here is 20. So that is my outer radius right there. So the volume right here is going to be equal to pi, and the integral from 2 to 5, we're going to say 20 squared, and then we're going to subtract. Now we have to define what this inner radius right here is. This is what we're going to subtract away, the volume of this empty space right here. That's what we need to subtract away. So how do I define what this distance is right here? Well, always measure from here. So it would be all of this distance right here, yeah? So 20, subtract away the distance here, which is g of x. So this right here is 20. If I subtract 20 and g of x, that would give me this distance between the axis of rotation and the function. So that inner radius, I'll call it r sub 1, would be equal to 20 minus g of x right there. That should give me that empty space. So yeah, so that's my inner radius. So 20 minus g of x, make sure you square all of that, dx, and this right here should give you the volume as described here. It's a washer method. That makes sense right here. Yeah. So imagine that we're finding the volume of a cylinder, like this right here, being revolved, but then we're also subtracting away all of that right there, which is that volume right there. Okay, I've rotated it. Anything else? Write, but do not evaluate. We love those. Okay, I think that should cover it. And that's everything for question 6.